Okay, we're going to go over section 3.5. It's equation solving and mathematical modeling. Okay. One of the first examples that you need to solve is going to give you an equation, and you need to go through the process algebraically to solve it. So say that you have this equation, 20 times 1/2 raised to the x over 3 equals 5. So first step, we want to move this 20 to the other side, so we're going to divide both sides by 20. The 20's on this side cancel, and I end up with 1/2 raised to the x over 3 power is equal to 1 over 4. Okay? We want to make this so that they have the same base. So I'm going to change 1 over 4 to 1/2 raised to the second power. It is the exact same thing. I'm just changing it so that they have the same bases. Because once they have the same bases, then I can say, oh, if 1/2 raised to the x over 3 is equal to 1/2 to the second power, therefore x over 3 must be equal to 2. And then we can multiply by 3 both sides and find out that x is equal to 6. Okay. That's the first equation. Let's try another example. Example 2. This time we're going to have e raised to the x subtract e raised to the negative x divided by 2 is equal to 5. Okay? This time, we're going to solve it graphically. Okay? So we're going to graph e raised to the x subtract e raised to the negative x divided by 2. Okay? Then you're going to press the tab button and you're going to graph 5. And this would be y equals. And this is y equals. Graph them and then find the intersection. Okay, so I'm going to change screens and I'll do it on the calculator. So switch this over and pull this up. And let's graph it and find the intersection. So here we go. New document, graphs page, and let's make it a fraction, so control divide. And we're going to put in e raised to the x. And an arrow right, so if the cursor goes down, minus e raised to the negative x. Let's do something weird here. Get rid of that extra. And it's over 2. And enter. And it gives us this graph. Okay. Now press the tab key and type in 5 and enter. And now just find the intersection. So menu, analyze graph, intersection. Find lower, upper bound. And so here's our point. Our intersection point is 2.3, 5. So our x value is 2.31. So I'm going to switch this back. And our answer is x equals 2.31. Okay. Now, we could do this equation algebraically as well. So let's go through the steps in finding the answer algebraically. Okay. Example 2. Same equation, e raised to the x, subtract e raised to the negative x over 2 equals 5. So first step would be to multiply both sides by 2. 2's cancel out, and I get e raised to the x, subtract e raised to the negative x equals 10. Okay? Now, we are going to multiply both equations by e as well. Okay? So I'm going to times both sides by e. In doing that, e to the first times e to the x gives us, oh, there's one here and there's one here, so it's 2e to the 2x minus I changed my mind. We're going to multiply it by e raised to the x power. So that's where I get e raised to the x times e raised to the x is e raised to the 2x. Subtract e raised to the x times e raised to the negative x gives us e to the 0. And then over here we're going to have 10 e to the x. Okay? So now we know that e raised to the 0 is 1. So we have e raised to the 2x, subtract 1, equals 10 e raised to the x. Let's get our 10 over to the other side. So we're going to have e raised to the 2x minus 10 e raised to the x minus 1 equals 0. Okay? Now, we're going to substitute. We're going to say that w equals e raised to the x. Okay? So if I do that, this becomes w to the second power minus 10w minus 1. And then we could solve it like it's a quadratic, using the quadratic formula. Quite frankly, just graphing is much simpler. Okay? Let's do the next example. Example 3. Example 3 is log x squared equals 2. First thing I would do is change it to the exponential. So this is basically log base 10. So I'm going to switch it to the exponentially. So it would be 10 raised to the second power equals x squared. And to solve this, then we have the square root, take the square root of both sides, and so x equals 10. That one's pretty simple. If you change it to the exponential form, it's much easier to figure out what to do because we're used to seeing things in the exponential form rather than the log form. Okay? Now let's solve one with natural logs. Let's go over example 4 real quick. We have the natural log of 3x subtract 2 plus the natural log of x subtract 1, and this equals 2 times the natural log of x. Wow. Okay, so a couple of ways of doing this. You could, again, graph you're going to graph y equals the natural log of 3x minus 2 plus the natural log of x subtract 1. Then graph y equals 2 natural log of x and find the intersection. Okay? That's all the examples I'm going to go through right now. It should get you started.